first part was double salt and the coordination compound there we had seen. So which of the following represent a double salt and a coordination compound? So you need to identify the set representing a double salt and a coordination compound respectively.
So what is the second option?
The second option is NiCl2.3 En. That En is ethylene diamine, right? If you remember.
Okay, sir.
FeSO4, NH4 whole twice SO4. So the double salts will completely lose their identity. Okay, when put into water. Is it clear? And they split into their constituent ion. All ions get separated. But in coordination compound, that part of it remain intact. It doesn't separate completely. Okay, so double salt and a coordination compound respectively you need to look at, right? You know, there are basically three common double salts which we have studied. So three common double salts were potash alum, right? Potash alum was K2SO4, Al2SO4 hydrazed or 24H2. This is potash alum. Okay, and this you know that is being used to just purify water, right? And it splits into potassium ion, aluminum ion, sulfate ion, all get separated. Okay, this is a double salt. So this is a double salt. This is more salt, ferrous ammonium sulfate. That also splits into iron, ammonium. Okay, and this is carnallite. Then you put it in water, it splits into the all your potassium ion, magnesium ions, right? So this I hope is clear to you, right? So these are the double salts. So first you need to look for the double salt, and then you need to look for the coordination compound. Okay. So basically this is the option, right answer, because in option D, you are having both compounds as the double salt. One is the carnallite, this is the carnallite, and this is the more salt. Is it clear?
Yes, sir.
Christine, I hope it is clear to you, right?
Yes, sir.
Okay. The next part is which of the following is not an ambidentate ligand? Yeah. What should be the answer? Ambidentate ligand, what it was basically. If you remember, today also we have seen one ambidentate ligand. Which can connect from both the sides, right? Which both the side, there are two ways in which it can get connected. OCN, right? And it can be NCO also. Can you tell me the name, Jesli, of this ambidentate ligand? CN was,
Sir, I can't see your screen.
yeah, CN was cyanide, right? CN was cyanido, and this is cyanato. Okay, CYANATO, cyanato, and that one, the top one is cyanato O, because this O is being shown exclusively. This is written like this, okay? And if N is written first, means cyanate. The N is the donor atom. Is it clear? Cyanato N. I hope this is clear to you, right? Cyanato O and cyanato N. Got it? So this is an ambidentate ligand. Okay. Earlier names were cyanato and isocyanate. This was earlier name was isocyanate. Similarly, when you replace by O by sulfur, it becomes thiocyanate. Okay, thiocyanato S and thiocyanato N. Got it? So this is also an ambidentate ligand, right? Now next one. Suppose if you try to figure out NO2, then NO2, is it an ambidentate ligand? How we are going to figure out? It is like this, ONO, okay, or NO. Got it?
Yes, sir.
So this is also an ambidentate. Now we are only left with oxalato. Oxalato is not an ambidentate. So what kind of ligand it is? If it is not ambidentate, it is a bidentate. Means it is giving two lone pair. Is it clear or not? Right? It is a bidentate. Okay, so answer is going to be option D, the last option. That is going to be the right answer. Let me take an example from NEET 2024. First statement, homoleptic and heteroleptic. So just try to figure out what are homoleptic and heteroleptic complexes. Homoleptic, basically they are made up of just one type of ligand, and heteroleptic are made up of two or more than two types of ligands, right? Got it? Connected to a same metal atom or ion. So we need to figure out homoleptic and heteroleptic complexes, right? So reason assertion, they are very easy in NEET, okay, but you have to be very careful also, right? That thing you need to be very careful, because what happens, statement may appear correct when you read it initially and you can tick mark it correct, it may go wrong. You need to read it up to the end with full concentration. So this was the first statement, and the second statement is sorry. Very simple question. So what can you say about the two statements? First one is correct, the second one is correct, both are correct, and the second is the explanation of the first. Or if even if both are correct, the second one is not the explanation of the first one. Got it? So this, I hope the question is clear to all of you. Reason assertion question. So what should be the answer? Just and give the, tell me.
So both the statements are correct only, right?
Yeah, both the statement are correct. Absolutely. And is the reason also correct for the statement second? Is it the reason for the first one? Correct. Is it the statement second is the explanation of the first? Yeah, that is also correct. Got it. So second is explaining. So this is homoleptic, right? And this is heteroleptic. This is I have not mentioned it, whereas this is heteroleptic. Got it. So complex first has only one kind of ligand. That was the definition for homoleptic. Got it. And this complex has more than one kind of ligand, so that's why it is heteroleptic. So both are correct, and the second statement is the correct state explanation for the first statement. I hope this is clear to you. Okay. Next question is very simple. Okay. Basically, it is same that ambident that already we have covered, and it is talking about the ethylene diamine tetraacetate. Iron. This is also from NEET 2024. Is the NEET has given these options which I'm writing. So this question is very, very simple. Got it? So what should be the answer? Yeah, Justine. Yovita, tell me what should be the answer to this problem?
Option A.
Yeah, option A. Hexadentate ligand. Very simple, and this question has appeared in 2023 and again appeared in it was there in the 2021, and it was asking along with the denticity. It was in 2021 they have also asked about the donor sites. So uh, the question part was same, just a second. But they have asked about the donors sites. What are the donor sites, right? Mean the atom which are actually trying to give the lone pairs, that they have asked. Okay, so it is a very important complex ligand. So in option A, they have mentioned a bidentate ligand with with two N donor sites, nitrogen donor sites. Option B, tridentate ligand with three N donor sites. Three nitrogen donor sites. Okay. But here the options are very simple and you can clearly uh, make them out. Okay. So I'm going to change the options which were originally given in NEET. Okay. Little bit difficult. I'm going to make it. in order to know this, you need to know the structure of EDTA. Got it? So what will be the answer?
So option D.
Option?
D.
Yes. Option D is going to be the right answer because as we know that hexadentate ligand with two nitrogen, ethylene diamine. Okay, what is the full form of EDTA? It is ethylene diamine and tetraacetate. So you have four oxygen in the acetate and two nitrogen from ethylene diamine. So D is the right answer. Okay. Next question. So you have basic questions, but be careful because you can go wrong if you don't read the question very carefully. Okay. So let me start with another question. There are many questions given in your bonding part. Okay, bonding part we will be starting in the next class. Okay, so we will be able to do a lot of questions. Some questions related to the general introduction and all that we are discussing today. Okay. They have asked again the homoleptic and heteroleptic question, but they have asked in a very different way. Right? So they have, instead of giving you the formula, they have given you the names. So which of the following? So this is basically a question related to IUPAC nomenclature also. So which of the following is homoleptic complex? And this is very easy to see. In the square bracket, if you have just one kind of ligand, that is homoleptic. And if you have two different kind of ligand, that is heteroleptic. You can also write the structures of these names. Okay, that's the different part of the question. The answer to this problem is very simple. And that is which option? Very simple to answer this. Which of the following is a homoleptic complex? Homoleptic complex which has all same kind of ligand connected to a metal, right? Next is we can try to write the names also because it will help us to practice the IUPAC names. The answer is option A, right? Because how I'm going to write the name potassium is there. Trioxylato aluminate. Al. Oxalato is C2O4. It is a bidentate ligand. Got it? There are three oxalato. Normally, it is better to use stress, okay? Because it is an organic ligand. Aluminium is +3 as it is its oxidation state is written in the bracket +3. Oxalato, each oxalato carries -2 charge, so -6 because there are three oxalato, -6. So on the square bracket, you will have -3. Okay, so K3. This is going to be the formula of the complex. So I hope it is clear to all of you how to write the formula from the name. Is it clear? And this is homoleptic. This is from the NEET only, recent question. Okay, from NEET to 2023, right? But so basic questions are being asked, you know. We can just try to figure out how to solve them. Okay, just read the question very carefully. We are doing it one step ahead. I have asked you to draw the structures of these complexes also. Okay. So let's draw the structure of this complex. So first, figure out the metal, that is platinum. While writing the formula, you should write the metal in the square bracket. While for writing the formula, cation and anion, and while writing the square bracket, you should first write the metal, then you should write the ligands in alphabetical sequence. So amine is there, chlorido is there, nitrito N is there. Okay. But there are two amines. Is it clear? So NH3 whole twice. And there is a chlorido, which is Cl minus because it is O in the name. Nitrito N. Nitrito is NO2 or ONO? Okay, N. The donor site is nitrogen. So nitrito is connected through N. Is it clear? And this is platinum is +2. +2 minus minus. Okay. It is a neutral complex. Is it clear or not?
Yes, sir.
It is a homoleptic or heteroleptic. It is a heteroleptic complex because that square bracket consists of more than one type of ligand. Let's practice this. Pentaamine carbonato cobalt 3 chloride. This is quite simple. Write the name of the metal, that is cobalt. Okay, this is the cation. This whole thing is a complex cation. And the anion is chloride, Cl minus. But their numbers are not given. We need to figure out by the charges of each other. The cation and anion, what are the charges? Accordingly, we will put their numbers. So cobalt is there, and in the cobalt you have pentamine carbon. Pentamine is NH3 5. And carbonato as CO3. Carbonate, you know, calcium carbonate, CaCO2. So this is carbonato. Cobalt +3 is there. Okay. This is 0 charge and this is -2. Okay. So the charge is going to be +1 and on Cl it is going to be minus. Is it clear? So this is going to be the formula of the complex and this is going to be a heteroleptic complex, right? This is also simple. Just try it and let me know what is the formula. Triamine triaqua chromium 3 chloride. So this is the cation and the metal ion is chromium +3. You don't write the charges in the formula. Got it?
Yes, sir.
And you mention actually the formulas. Okay, charges you need to, and they are mentioned. You need to know. Okay, internally you need to know because otherwise you will not be able to figure out what is the charge, total charge of the square bracket, what is the total charge of the metal or cation. That you will not be able to figure out. Okay, chromium is there. And this there are 3 NH3 triamine. NH3 whole thrice, right? Triaqua. There are 3 aqua ligands. Okay, and this is chromium was +3. I'm writing above it, but we don't write actually, just we are writing for the sake of calculation. Okay, so this is neutral, this is neutral, the total charge is going to be +3, right? So, and the anion is Cl minus chloride. So I need to put 3 chloride ions to balance this +3 charge. Okay. Once the formula is finalized, remove these charges. Is it clear? Any doubts in this?
Yes.
Okay. So this is how they are asking about the different types of complexes. Let's do another question. This is from NEET 2018. Okay, this is a neutral complex. Okay, what is the name of this neutral complex? Can you tell me? Very simple. You can try to name it, and then I will write rest of the question. Ligands are named first, and how you are going to name them? Very simple. There are 5 ligands, all of the same kind.
pentacarbonyl,
Yeah, penta, yeah, carbonyl, exactly. Pentacarbonyl. And what about the metal? Should I write it as iron? Should I write it as ferrate? Ferrate, ferrous, what should I write? This is no special names for the metal. Okay, if it is neutral or positively charged. But if the square bracket is negatively charged, write the Latin name ending with 8. Okay. So don't write ferrate and all. Just write iron. Got it? And what is the oxidation state? Carbon monoxide is neutral. The pentacarbonyl iron, this is penta, not right. Iron 0. Got it? So this is a metal carbonyl. Okay. The question which they have asked in your NEET examination was it is a tetranuclear complex, mononuclear complex, is it a trinuclear complex, or is it a dinuclear complex? This is from your NEET 2018. So this seems very easy, but if you don't know, you can make mistake. What does this term means? Got it? So this mononuclear, dinuclear, trinuclear, tetranuclear, it refers to, listen to me very carefully, it refers to the number of metal ions. Got it? In a complex. Right. So basically, this case, so I hope it is clear. Number of metal ions in the complex. Don't think about the nuclei. There are many nuclei in this. Only the metal atoms, right? Metal. How many metals are there? So only this iron is there, right? Is it clear? So this is going to be a mononuclear complex. Okay. For example, if you take FeCO5, that will be mononuclear. Fe3CO12, that is going to be trinuclear. Got it?
Yes.
And CO2CO8. This is dinuclear. They are all homoleptic complexes. Based on the number of metal ions, it is decided. Got it? Is it clear or not?
Yes.
Now, so very important, because this is a metal carbonyl, and we are going to discuss some other details about this. If if I talk about the type of ligand, these are metal carbonyls. There is one more thing, and these are non-classical complexes also. Okay, classical and non-classical complexes. Like suppose if you have a metal ion and there is a ligand like NH3 or water, aqua, amine. Normally that this is a classical complex. Got it? In non-classical one, what is basically happening is that for example in Fe and CO, the CO is donating its lone pair and CO is also accepting a pair of electron from iron. So it is a two-way bonding happening. Got it? Donation, acceptance. Got it? So this is such ligands will be considered to be categorized under non-classical complexes. Is it clear? Okay, you have a lot of questions on this also. Okay, we will cover that once we cover the bonding part, because there is something related to bonding in it. So we need to get through the bonding part. That is very important. Okay. Then only we will be able to understand those questions related to, they are related to carbon oxygen bond length. Okay. That you need to. That will be covered in this. First, we will be covering in the CBSE class, and then we will be covering it in this class, right? So this I hope is clear to you. Okay. Next is the magnetic moment. Okay. They have also given the question from directly taken from your NCRT, the one which we discussed. It is similar to that. Yeah. Not exactly same as that of NCRT. Very similar question. And they have asked, this question was there in the NEET 2022. Okay. And they have given the IUPAC names of written below, but I'm not going to write the options because I know you can tell the directly, you can tell me the IUPAC name of this complex. So this is the cation and that one is the anion, right? So di aqua silver. Okay, one. And then I will start writing the name of the anionic part starting from its ligand cyanide. And here in this case, I'm going to use the Latin name with 8 as its ending. Cyanide. What's the Latin name? Argentate. Silver is +1, but because this is +1, -1, -1, there are 2 cyanide and the whole bracket became acquired negative charge. So if you write the name of the metal ions present in a negatively charged square bracket, you write the Latin names and you use the suffix "ate" for the metals. Okay, so this is the complete name, and so this is being asked in your NEET 2022 examination. Okay, and they have given various options, but instead of writing the option, I directly discuss the answer with you because you can clearly do this question. Okay, so very simple. You can do the complete paper of NEET, but very important part is you need to read each and every question very carefully. Don't make mistake in reading. Okay. So let me end today's class, right? Okay, and let's proceed with the bonding part in the next class. Okay. Okay. Bye bye. Take care. Good night.
Thank you, sir.
Thank you, sir.